In this video, we'll be looking at net ionic equations for chemistry. Starting off, what is a net ionic equation? Net ionic equations are ways in which we can write chemical reactions to only show the active substances in that reaction. Simply put, we're going to write a chemical reaction, but we're only going to include the substances that are undergoing chemical changes. For instance, the reaction AgNO3 aqueous plus NaCl aqueous will react to form AgCl solid plus NaNO3 aqueous, shows the formation of silver chloride from silver nitrate and sodium chloride. However, as you probably know, there's a simpler way in which we can write this reaction, which reads aqueous silver ions plus aqueous chlorine ions will form silver chloride solid. So where did the rest of our reactants go? Where are the nitrates? Where are the sodiums? As you know, when dissolved in water, soluble substances will turn into ions. And so that's what we can do with this equation. We can take all these soluble substances and turn them into their ions. So let's do that for every single one of the substances in this equation. Sorry if this looks confusing. Let's just break it down again. We're taking all of our soluble substances and turning them into ions. So silver and nitrate will form silver ions and nitrate ions. Sodium and chlorine will form sodium ions and chlorine ions. Silver chloride itself is a solid, so that's just going to say as solid silver chloride. And sodium nitrate will again form sodium ions and nitrate ions. As you may also notice, some of these ions look identical on both sides of the equation. For instance, we have a nitrate ion and a nitrate ion on both sides of the equation. And we have sodium ions and sodium ions on both sides of the equation. Those are what we call spectator ions. I had to remove the net ionic equation definition to make room, but a spectator ion is something that exists on both sides of our equation in the exact same form. And just like you can do in algebra, we can eliminate these spectator ions from our equation. We have aqueous nitrate ions on both sides of the equation, so we can cancel them out. And we also have aqueous sodium ions on both sides of the equation, so we can also cancel those out. And after cleaning up our messy eraser marks, what are we left with? Aqueous silver ions plus aqueous chlorine ions will react to form solid silver chloride. And as you can see, both of these equations are the exact same. They are the net ionic equation for our original equation up here. We went from the original and we formed a net ionic equation. And so that's why net ionic equations is actually a pretty simple part in AP chemistry. All you really have to know is the two definitions. You need to know what a spectator ion is and what a net ionic equation looks like. And as I just did here, you need to be able to form one off of the original equation. Let's do some more examples right now just to reinforce that and in case you're confused. And in case you are confused, here are the three main steps to writing those net ionic equations. We just got to start by balancing our equation. Again, we then split all of our soluble substances into our ions. And then finally, we just cancel out ions that appear in the exact same form on both sides of the equation. Also, just a quick comment, you've probably seen by now it's pretty important to know which substances are going to dissolve and break up into ions. I'm going to insert this solubility chart here, which you should reference in case you're not familiar with it yet. For the AP Chemistry exam, you'll need to know which substances are soluble. I'll be sure to post a full video over solubility in the near future, but for now, feel free to just reference this chart whenever you need it. Alright, so for our next example, let's turn this equation into a net ionic equation. Just make sure that you're going through all the steps. Remember that step 1 is to make sure that our equation is balanced. Counting up my atoms and putting them in the following table, I can see, yes, my equation is balanced. So I can go to my second step where I'm going to break up all of my substances which are soluble into their individual ions. My first one, 2Ki, will become 2 positive potassium ions and 2 negative iodine ions. For PbNO3, make sure that we're being really careful with reversing our charges. Remember that when you form an ionic compound, we have to cross over our charges. When we split up ionic compounds, we have to reverse this. So we take the implied 1 below lead and we put it back up there, and we take the 2 from nitrate and we put it back up there. And thus we will have Pb2 plus aqueous and NO3 minus aqueous. But what's one other thing we have to remember? We need to have a coefficient of 2 in front of our nitrate. Why is that? Well, because our charges have to cancel out. 1 negative charge is not going to cancel out with 2 positive charges. But 2 negative charges will cancel out with 2 positive charges. This is all stuff from Unit 2, So if it's not as familiar anymore, I recommend watching my 3-part series over ionic bonds on my channel. Our PbI2 is going to stay as a solid. That's not going to dissolve. And then here we're going to get 2 positive potassium ions and 2 nitrate ions. I'm sorry, I ran out of room. I should have spaced that better. But so now that we've got all that split up, let's just go crazy and cancel whatever we see. I'm going to cancel out my potassiums because those are on both sides of my equation. I'm going to cancel out my nitrates because those are on both sides of my equation. And so the only thing I'm left with, 2 aqueous iodine ions, will combine with 1 2+ lead ion to form solid lead-2 iodide. And so again, the 3-step process is pretty simple. Just make sure we're staying organized and we know what's going to dissolve. And also make sure, if you've forgotten, we have to recross over our charges whenever we split up an ionic compound. To finish off this video, let's answer the following question. Equal volumes of 0.2 molar solutions of lead-2 nitrate and potassium bromide are combined to form lead-2 bromide as a yellow precipitate. Write the net ionic equation for this reaction. Alright, this one seems a lot more complex than the other ones, but it's really not. First of all, there's a lot of fluff that we can just ignore. Equal volumes of 0.2 molar solutions, I don't care about the molarity. That has nothing to do with my actual equation. Same with the lead-2 bromide being a yellow precipitate. Well, I mean, good for it, I guess, but why would I care about that? All I care about for the net ionic equation is knowing my original chemical reaction formula. So let's write that out. Let's write out lead-2 nitrate reacting with potassium bromide to then form lead-2 bromide. And so don't stop there, okay? Because what I have written now breaks the fundamental rule of chemistry, the law of conservation of mass. With the equation I've written, my potassium and my nitrate just evaporate into thin air. That's not how I can have my original equation written. So I know that as a byproduct, I'm gonna have to be forming potassium nitrate. And so the first step is that I have to balance this equation. First thing I notice, my lead is fine. I do have to double my nitrogen on the right side of the equation. So let's double that. And with doing so, my nitrogen is good and my oxygen is now good. But so now I need twice as much potassium on the left side of the equation. So let's put a coefficient of 2 right there. And that'll fix my potassium and my bromine problems. So my equation is now balanced. Because it's balanced, let's go to step 2 and break this up into its individual ions. And I'll be sure to write a little bit smaller this time. Again, for splitting up my lead-2 nitrate, make sure that I'm reverse crossing over my charges. For splitting up my potassium and bromine, make sure my coefficient of 2 is going to be following it. My lead-2 bromide is the precipitate which I am forming, so that's going to be a solid. That's not going to dissolve. And then lastly, for splitting up my potassium nitrate, again, just make sure that this coefficient is following in my answer. And now all I have to do is step 3. I'm just going to cancel some stuff out. I've got 2 nitrate ions on the right side and on the left side, so I can get rid of those. I've got 2 potassium ions on the left side and 2 potassium ions on the right side, so I can get rid of those. And my final answer for this question is lead-2+ ions react with 2 bromide ions to form lead-2 bromide as a yellow precipitate. This right here is the net ionic equation for this reaction. And with that being said, that's all you have to know for net ionic equations in chemistry. If any of this was confusing, I recommend rewatching parts of the video. If it's still not making sense, take a break and come back after. Thank you so much for watching.